Hey guys, welcome to my YouTube channel. I am Timmy Tayo, and this is going to be a quick guide to procedural animation using inverse kinematics and Unity's animation rigging system. So first off, I'd like to apologize for sending this video out quite late, at least 2 days late than the date I promised I was going to send out the video. So without any further delays, let's move right to the tutorial. So first things first, I have put together another terrible insect model in Blender. Made it all red this time instead of all black, and I'm just going to drag that into the scene. It's facing the other way, but that is the same orientation for the original, and so we just inspect that and we notice that we have our rig. It's fully rigged. I fully rigged this in Blender before bringing it in, and it's just a regular rig. The abdomen has the left and right shoulders connected to it, same thing as the thorax, and then the legs are all connected to that. And we have our original insect here, and we just notice that there is a very similar form between the two of them, with the exclusion of this rig. So this rig right here is the Unity's animation rig that I got from the Unity animation rigging package. And so the first course of action to transfer the procedural animation to a new model, a new rig model, is to copy the Unity's animation rig and paste it on our new rigged insect model. So I'm just going to paste that. Right, so once we have our rig in, I'm just going to rename this to, let's call it IK insect 2. And yeah, so first things after copying the rig in is to inspect. I'm basically just going to be transferring over all the components from the original IK insect, IK meaning inverse kinematic, onto the second IK insect. And this is just to show you the steps that are going to be involved if you want to transfer the motion, if you want to transfer the animation of my model onto a model of your choice. So as I'm going over the steps, I'm just going to be explaining along the way a few concepts that were used in developing this project, and hopefully that will give us some insights into the general approach to procedural animation using inverse kinematics. So the most important script here is the IK insect controller, which we have here, and I could really just copy this first of all and paste it as a new component on my new game object. But I'm also going to have all the references copied and pasted, which I really don't want. That's referring to the feet, because on this I have different feet, whereas on this rig I have my own feet. So I'm just going to expand the feet on this rig and reassign the references for front right, front left, and hand right. And if anybody has explored the project, anybody watching this video, if you've explored this project already before, you'd notice that I actually accidentally swapped the left and right nomenclature for the rig, for the bones. That was an accident that I was too lazy to correct, and that still remains. So just out there, I do know my left from my right. Trust me, I just forgot while I was making it in Blender. Yeah, so the next most important thing we need to bring in is the rig builder. Now this is the bone renderer. This really just allows us to see this interesting blue thing that's going on here. To be honest, it's not necessary, and it takes a very long time to assign all the bones, so I'm not going to bother with the bone renderer for this tutorial. I'm just going to stick with the essentials. And talking about the essentials, the next I need is the rig builder. So instead of copying this, I'm just going to go back here and create and add a new rig builder and assign my rig here, which is this, to this rig builder component here. All right, okay, so I'd like us to just quickly talk a little bit about inverse kinematics in relation to game development. And it's a fancy word, I know it's a fancy word, or a fancy phrase as it were, 2 words, but it's really quite simple in concept. I mean, it's just the reverse or forward kinematics. And kinematics is simply just a word that denotes movement, relational movement, a relational transform movement. So where you have a hierarchy of parented transforms, that's, for instance, you have one transform parented to another transform parented to another transform. Each of those transforms position and rotation are relative to the position and rotation of their parent, and that's what we call kinematics in game development, because a kinematic body operates independently of physics, and that's the only kind of movement really that parented or local relational orientation can apply to. So when we talk about inverse kinematics, what we're really trying to say is just that instead of the relational positions trickling down the chain of parenting, it trickles up the chain. So what that just means is instead of the child position and rotation depending on the position and rotation of the parent, you infer the position and rotation of the parent based on the position and rotation of the child transform. And the importance of that is just so that we can have a very interesting situation where if we move one of the children, we're able to infer the correct position of the parent from that child's current position and rotation. And so that just allows us to create some efficiently interesting animations where we don't have to, specifically set the position and rotation of every bone or every joint in the skeleton. We can just do it for the major endpoint and the system infers the other positions. Alright, so I think that is a good 2-minute overview of what inverse kinematics is. And so before I continue, I'll just jump into the code so we can take a little look at what is actually happening. Alright, so we have a lot of green, a whole lot of green, a lot of comments. Yeah, I would not pretend and say the code does not have a little bit of complication. In all honesty, it took me about a week in total to write this, and when it takes you a week to write a single script of less than 600 lines, yeah, that probably means that there are some complicated elements in it, which is fine because procedural animation isn't supposed to be the simplest of subjects. But to be honest, it isn't really that complicated either. All we need to do is follow the process and to understand where we're coming from and where we're trying to go. So the heart of the script is the movement of the feet, which happens here, move foot right here. And all I do here is I choose a foot, and actually what I'm choosing is an IK target, which simply means one of the endpoints, so that if I move that endpoint, it can affect the parent transforms and just move the other parents in a realistic way, like they were real joints. And once I get the foot IK target, I get its position, its stable position, and stable position here is just a fancy property that I just made that would always return to me the position of the foot the last time it was on the ground. If the foot is not on the ground, stable position returns to me the position of that foot the last time it was on the ground, and if it's on the ground, it just returns to me the current position, obviously. And once I get the stable position of the foot, all I have to do is raycast a little forward using my step stride, which is how far I want to step. And if I find a step, I know that that's my next step that I'm moving towards, and if I don't, I just basically escape out of this function. So here I have this little snippet that says the rest of this function is unnecessary. If you want a simpler looking animation, you could just uncomment this out, comment the rest of the function, and use this version, which is true. Most procedural animations that I have seen around don't really control the fine-tuning of the animation by themselves. They just move the IK target towards a particular position using some incremental function like move towards or linear interpolation or spherical interpolation or something like that. But here, because we are, how would I say, compulsive, okay, that's a bad word, because we are specific and we like to dive into the details and we are nitpicky, we are actually controlling our animation exactly. And what that just means is I prepared animation curves for the X, Y, and Z axis, and I am sampling those curves to determine exactly how the foot travels in world space during the step animation. And by editing those curves, we can change how the animation looks and how it plays. And because this script is a specialized kind of procedural animation where the positions of the feet are actually what determines the position of the main insect or the main parent, what that causes is that the animation itself is actually a very pivotal variable in determining the real motion, which I can call the root motion of our parent insect. And we can kind of juxtapose this to most regular procedural animation approaches. Not all. I've seen some that also use this step driver kind of approach where the steps are actually driving emotion, but a lot of procedural animation approaches just use the steps as a kind of cosmetic animation where they're actually moving the parent on its own using regular character controller kind of mechanics, and then the feet just adapt to the motion of the parent. So once the feet is located at a point that is too far away from its reference position with respect to the parent, it kind of just snaps into place, and that kind of mimics a kind of stepping animation to a good extent. But I was going for something more specific. I wanted the feet to move first. I wanted to be able to take a step and determine whether that step was good or not before landing it. I also wanted to be able to do some fun stuff like the way the insect claws up, the way the insect's feet can go up on its own and come down. All those are features that were only enabled by the fact that the feet are actually the motion drivers here. And so to be nitpicky about the animation and to control the animation very exactly, that is the real reason for the rest of this function. And we can look at it more closely, but really I already described all of the steps. We first of all obtain the non-animated world step, then we convert it to the local vector using a reference for direction, then we sample the animation curve and process the vector so that it looks animated. Processing the vector just means taking a small portion of it to apply for this particular frame just so that it plays an animation when we're actually using it, and then we convert it back from local to world and basically just apply it to the foot. So we have a few other functions like the offset foot, which basically offsets the feet, two of the feet, so that the motion can look as natural as possible. If not, the motion is going to be consistently biased towards one side at all times. We have our function that controls the nav mesh agents. We have our function that controls the rotation of the insect in terms of roll, pitch, and yaw. And this is just to make the motion look more natural, because without this you have a situation where the feet are moving but the body is just kind of staying completely flush and perfectly parallel with the ground, which looks weird. And its forward facing is kind of a hack that I just used for the nav mesh agent so that it just knows where it's going. I'm going to talk about two things. The first is the move forward coroutine. And the move forward coroutine is just a really wonky coroutine that I wrote that very specifically carries the feet and moves them one at a time to create as realistic a motion as I could possibly mimic. It runs in a loop. Clearly, this is the main loop it runs in. The first part of it is really just prep, where I actually apply the offsets. So this is where the offset actually gets called, and I stabilize the feet and do a few other things. And once I'm done prepping, I then enter the main loop, which moves the feet one at a time using a specific delay, so that I can over time have a very specific pattern of movement of feet, which creates that very interesting motion that for some reason got 5.5 thousand views on YouTube. Who knew? Anyways, second very important thing I'd like to talk about is not in this script but in a different script called foot IK target. So this is a script that exists on each individual foot of the insect, and that reminds me, I would have to put this script on each of the individual foot for our new model for it to actually function properly. Now, okay, in this script we have, it's basically just, it used to be just a helper script to access the important properties of each foot without having to do too many object references. But then eventually I had to add a quite pivotal piece of code on this script, which is called get rest position. In the first version of this project, if you try to rotate the insect during playtime, the whole animation just like spazzes out and everything just breaks down, because I was using the forward reference direction as my only reference direction, and if you try to change that reference direction, everything just gets weird. Get rest position just updates the rest positions so that no matter where I turn, it knows where to put the feet such that the insect is at a position of rest. And once I know the position of rest for the feet, I can pretty much just move them from those rest positions and the motion stays natural, everything stays the same. So that became very, very important for implementing a turn feature where the insect can now turn around, and the function that allows it to turn is this guy over here, take many steps to center. Now take many steps to center is one hell of a bad boy coroutine. It's quite long, but anyways, all that happens here is I have the insect facing, let's say, angle 0. Let's say angle 0 is the world forward vector, and I want to turn to, let's say, angle 90. Let's call angle 90 the world left vector. And so the first thing I do is I divide that into a number of subdivisions, and then for each subdivision I create waypoints, and waypoints are simply different stop points for a foot in trying to get from its current position to its target position. The reason for that is the turning is basically just faked. The turning uses cosmetic steps where I'm actually just rotating the insect and then cosmetically adjusting the feet so that they stay in their correct positions. But it has to be exact because the feet are what control the actual position of the insect at the end of the day when I start walking and when I do my body control. And yeah, I think that covers all code to a reasonable extent. So let's now finish up with this. So all we have left to do, we already have, oh no we don't. All right, this is IK insect 2 and these are the feet. So you can see they're targeting the wrong components. This is all, you know, I need to reset this so that it goes to my correct person. Then I need to position these so that they match the actual feet. So I'm just going to move these a bit, adjust them so that they match the feet as closely as possible. And what I'm going to be doing here is once I move one, right, I'm going to basically just copy its values and paste it on the left side and then negate the X component to just kind of make it exact. So I do it for this one and then do it for the right too, and then do the same thing. So that's just a way to make sure your IK targets are symmetrical. You could just copy it, paste it on the other side and negate the X value so that it kind of just flips around the X axis. So just copy the position, paste it, and just flip that. All right, so next we kind of need to fix these. So you can can see on the IK targets we have foreleg and all of that, and they are targeting bones on our they're supposed to target bones on our rig, on our model's rig, but right now they're targeting bones on the old model's rig. So we need to reassign those bones to use our actual bones. So we're going to expand this, so expand the abdomen and the thorax. Let's just expand everything so we can easily assign. All right, head doesn't have anything important. So yeah, this is, so you can see it's flipped, right? So we have the left being assigned to the right being assigned to the left. Yeah, like I said, I messed up, but yeah, so we're just going to have to continue with that. So the target, first of all, is myself. Believe it or not, the target is the target itself. The root is the actual transform. I need that root to do the reference using the rest positions, to get the rest position. And yeah, I can now assign these, the end, the mid, and the upper. So for right, I assign the end, the mid, and the upper, and I do the same thing for hind. And I think I messed something up. Lower, okay, lower, no end for this one. And oh wait, something is wrong. Hind leg. Okay, this is interesting. Okay, so I had it renamed. I renamed it in the last one, and I didn't rename this one yet. So that's why it's looking like this. Okay, so this is correct. Hind leg is what the issue is. Then middle, and leg middle. No. Okay, this is left. I'm supposed to be using right. Sorry about that. So let's expand the right. So lower right and lower middle and upper. Then we assign for the right using the left. Unfortunately, it's flipped. Sorry about that, guys. And upper. All right. So let's reassign the roots for all of them as well. So reassign the roots right there, and then the targets as well. Reassign the targets and the roots. Reassign the target. The root is already reassigned here. And lastly, reassign the targets and the root. Okay, good. So let's just confirm that I have everything. Just going to click make sure it's pointing to the right guy here and here. Click okay. All good. So if I did everything right, once I play this now, it should just work basically. I'm going to save this. I'm going to zoom out, play, and hope for the best. All right. So moment of truth, play. Whoop. Oh man. Okay, right. Very important. I forgot something very important. The navigation agents, because that's actually what tells it where to go. Yeah. So to do that very easily, I'm just going to I'm going to first copy this nav mesh agents, paste it here, paste it here, paste component as new. I'm going to leave all the settings. Then I'm now going to copy the nav mesh agents controller script. Very simple script, to be honest. There's nothing to it. We can check it out if you want. I basically just, guys, this is nothing. Raycast, get a position to move to and just update. Anyways, we paste it here, and yeah, okay, we need to reassign some stuff. The insect controller is this, the agent is this, and follow player. Yeah, so that's that. So save, and moment of truth again, play. Okay, there we have it, guys, and we have our two insects, moving hilly-nilly, wonky-donkey, just trying to find the player, just going all around the place, doing just doing their thing, as you see. So yeah, and guys, you guys know the main importance of IK is that, so you can see this where I have 4 feet and I can see 3 of them are on the stairs while 1 of them is on the ground. So this kind of orientation is very hard to obtain using regular animation, because animation is cosmetic. It's hard to kind of position stuff like this, and that's why you have inverse kinematics and procedural animation kind of taking the wheel to achieve kind of these more realistic stances. For instance, like in The Witcher 3, where if your art is near a tree stump, he can put 1 foot on a tree stump and his other foot is on the ground. So yeah, that's basically the use of this kind of thing. So yeah, thanks for tuning in. My roommates are waking up now. I'm going to edit this part out of the video, obviously. So yeah, that's it, guys. See you next time on my next video. I don't know when it's going to be. Peace out.